Well, good morning, everyone. First of all, my apologies for being late. I had some troubles with the flights this evening, coming from Curacao. So my name is Kelly Latijnhouwers. I work for SECORE International, and I'm based at the CARMABI research station in Curacao. I was supposed to tell you guys what SECORE does earlier this morning, so I'll quickly give a recap on that because I missed that presentation. So SECORE is an organization that focuses on doing coral restoration using larval propagation. We basically have four big pillars that we use to support our restoration work. First one being research, very fundamental research, and also very applied research. So, for instance, figuring out when corals spawn, but also coming up with new technologies to increase the scale of doing larval propagation work. Another pillar is definitely outreach and education, and more specifically training events and teaching other people how to do this type of restoration work. And then there's technology and technology development, which basically links back to the applied restoration part. Having that said, I'm going to tell you about larval propagation and doing that in the field. Jamie, thank you so much for your presentation. I'm definitely always a little bit jealous when you say that you can make coral spawn whenever you want. Now it's up to me to make you guys feel excited again about doing this in the middle of the night with very, very long hours in the field. But there actually is a certain charm to it, so I hope I can convince you that that's true. I'm going to try to do that by... Yes. By first taking you through the steps on how to do larval propagation in the field. Some of you may have already seen this, for some of you this may be new, so I'll try to go through it fairly fast. Then I'll take you a little bit through the history of doing this type of work in the field, because it wasn't always as easy as it's going to sound like today. And then we're going to talk about new tools and technologies being developed to increase the scale and success of this type of restoration work, and mostly the technologies that are being developed by using inter-island collaborations, such as the ones between, for instance, Curacao and Bonaire. The coral life cycle. I am fairly sure Jamie already took you through this a little bit, so just a very quick recap. Basically, I'm going to only talk about broadcast spawning corals here, because we can also do this type of work with brooders, but it's a lot harder to do in situ, so I'm going to focus solely on broadcast spawners here. That's the hermaphrodites and the gonochoric species. Basically, they release their gametes into the water column, where fertilization occurs. These embryos will turn into swimming larvae. They will settle back to the reef, where they grow into larger colonies, and eventually they start spawning with the natural population. When this entire process goes well, this entire process will create a lot of new genetic diversity, because every new year with a new spawning event, a lot of new individuals are created. But of course, like with many other things on coral reefs, this is not going very well anymore. So basically, for all the steps of larval propagation, the life cycle of corals, we need to give them a little helping hand. So I have a very simplified version of the coral life cycle here, because there's four main steps that we give corals a little helping hand to achieve larval-based restoration. The first one being gamete collection. For hermaphroditic coral species, so when males and females are, when colony is male and female at the same time, it's fairly easy, because these corals make little sperm and egg packages that are they're made out of lipids, so they float to the surface really easily. So we can actually place these specially made coral spawning nets over every single spawning coral, and the gametes will float up, and eventually they will come through this funnel into a little tube that's inserted here. I lost it at the airport this morning, but normally there's a tube here. And then that tube is where you collect your spawn. Then you have a lot of divers underwater with a lot of these nets, so you can collect from as many corals as possible. That looks a little bit like this. Very straightforward. For gonochoric species, so when males and females are separate, it's a little bit harder, but it's actually a lot of fun. So the female corals release individual eggs into the water column, and the male corals release sperm clouds into the water column. So how do we mix that? Like, we can't really place nets on it because these eggs, even though they're buoyant, are not closely as buoyant as the sperm and egg packages, and the cloud just dissolves into the water column. So we actually use syringes to collect from these corals, which definitely requires a trained eye, but it's a lot of fun to do. You kind of feel like you're in Ghostbusters. You have to hang in front of these corals and wait for them to release, and you have to collect from really close to the colony, because otherwise it gets too diluted into the water column and you can't use your collection anymore. But in the end, for both types of corals, you have your collection vessels, whether it's tubes or syringes, and you have to bring those together to go to the next step, which is larval rearing. Larval rearing consists of basically two steps, which is fertilization and embryogenesis, which are both like the most sensitive steps of coral spawning work. The idea is that you bring your spawn collection into a lab setting or a bench on the beach or a boat or a pier, it doesn't matter, as long as you can bring all of your collected spawn into a vessel where you let fertilization occur. We definitely always advise to never ever put all of your eggs in one basket. So we always have multiple containers where we let fertilization occur, just in case something happens to one of your containers, you still have the rest to work with. After fertilization occurs, and typically for most of the Caribbean species we work with, nowadays, we actually can reach almost 100% fertilization. So that process we've kind of narrowed down pretty okay. Then these embryos start going through embryogenesis and development. And this is definitely the phase where you do not want to touch your culture. It's very important that like the moment these embryos start going through, the eggs start going through cell divisions, they are becoming super sensitive. And this process can take 12 hours up to like 4 days, depending on the species. So it's a very species-tailored approach of knowing how long you should leave your culture alone before you can get swimming larvae. Which brings us to the third step of larval propagation work, which is the settlement phase. Now, in nature, when everything would be going well, swimming coral larvae move down from the water column to the reef, and they find their place to settle. And actually, coral larvae can do pretty cool things. They are not they look like tiny little dots, but they can actually do a lot. So they can, for instance, sense the vibrations of the reef, so they can hear reef sounds, so that they know that they actually should swim towards the reef. And then once they're on the reef, of course, for instance, the appropriates need to settle really shallow, whereas a variety of other species needs to settle deeper, and they can actually sense lights and pressure, so they know exactly which depth they should be at. And then they need to make a very, very more detailed choice about where to settle on that reef, because corals are attracted to crustose coral and algae, CCAs, and they are actively repelled by turf algae, macroalgae, and other harmful organisms, and they can actually smell where to go to settle on that reef. But of course, with reefs degrading as they are at the moment, it's becoming harder and harder for these corals to find a suitable settlement surface on the reef, so we are giving them a little helping hand by providing settlement substrates. These are basically just, in this case, ceramic substrates that we allow the larvae to settle on, and after they settle and form a skeleton, we outplant them back to the reef. Of course, when you provide a larvae with something like this, they're not going to settle on it. It needs to actually smell like the things they like. So what we do is like 2 months prior to a spawning event, we place these in the ocean so that communities occupy these units, and hopefully after 2 months, they look like this. Definitely on top of this is also a lot of harmful algae, but we scrub those off. It's a lot of fun. You can ask the Reef Restoration Bonaire team. And then we provide them to settling coral larvae. And this works really well. The larvae then explore these settlement substrates and eventually settle, turn into primary polyps, after which they need to be outplanted to reefs. One of the major developments that we've been through in the last decade is the development of coral rearing in situ basins, or cribs. And I think most of you have seen pictures of these, but just a recap about this device is that we are now able to do coral larval rearing work. So basically the 3 steps I just talked about completely in situ without the need of land-based facilities. So your gamete collection still works with these gamete collectors, but then after that, the fertilization step occurs in your baskets, containers, and then after that, you bring the embryos into the crib where they develop into larvae and they can settle on the seeding units or the settlement substrates that are already in there. So basically, you can take your hands off of the culture as the moment embryogenesis has occurred. And then from this crib, you can go to the next step, which is outplanting the corals to the reef. The nice thing about all of these seeding units is that they have been developed to not need any manual attachment supply, so you don't need to epoxy them, you don't need to nail them, you can just wedge them in the reef crevice, which allows for very rapid outplanting with not too many people. And then there's, of course, the most important step, which is these corals need to grow into large coral colonies that eventually should spawn together with the wild population again. This is, of course, something that's more or less out of our hands. We can do coral restoration, but the stressors of reef degradations are still out there. So this is actually, other than the fertilization part, the hardest step. But we have had success. This coral right here, together with its siblings, is one of our most iconic cohorts. This coral was born in 2011. I don't know what happened with the title, but it was born in 2011, and it started spawning together with its siblings, together with the wild population in 2015, so when it was only 4 years old. Acropora palmata is a fast-growing Caribbean species, but overall this was a great success. And this is kind of the end goal of doing restoration, right? The goal of restoration is to eventually not have to do restoration anymore. So it's easy, right? It wasn't always that easy, though. I'm going to take you a little bit through the history of coral spawning work. And this slide says larval propagation 20 years ago. But in all honesty, like even when I started in this field, which was 11 years ago, this was still true. We did make severe progress since. But only like 11 years ago, everybody thought that larval propagation was absolutely not a feasible tool to do large-scale reef restoration. There was still limited knowledge on the reproductive timing of corals. The fertilization process, as well as the larval rearing process, was very hard and believed to be very hands-on and hands-on process that failed many, many times, and therefore large-scale settlement and larval rearing was just not considered feasible at all. And of course, survival success of corals that made it to the reef remained low. Strange things happened with the titles. I'm sorry for that, guys. One of the main reasons for this was that for the longest time, all the efforts of doing coral spawning work were focused on critically endangered species such as Orbicella fabulata and Acropora palmata. Those were the critically endangered species, so those were the species that people could get funding to work on. But it turns out, now that we work with many more species, these were actually the hardest ones to rear. We call them our princess species. They require a lot more hands-on work, they require a lot more effort, and they're actually really hard. By now, we've managed to, we know the reproductive timing and can successfully rear and outplant over 15 Caribbean coral species. And it turns out that, for instance, all the brain coral species are a lot easier to work with than the two princess species that people used to focus on. So when you start a larval propagation project, it might be easier to actually start with the brain corals to get to know how to do this type of work before you move forward with the harder species. A lot of progress has also been made in doing fertilization work. It used to be that people couldn't fertilize their gametes, or it would work one time and would not work the other time. It turns out every species likes different things, and every species does different things. The same for larval culture. This would be an absolute disaster if you would walk into your lab the morning after fertilization. And unfortunately, this used to happen a lot. But by now, we're a lot better at it because we figured out that also larval rearing is very different for every single species. For instance, knowing that some species take 4 days to develop, whereas other species only take 12 days to develop, was a major step forward. Another major step forward was actually starting to use these fat separators. It's a kitchen item. A lot of spawning work is very related to kitchen items. One of the things people realized not too long ago is that when you want to keep your culture happy, you've got to get rid of the sperm after fertilization has occurred. They didn't do that before. That's why you got these kinds of cultures the morning after. Because sperm that has not been used actually starts decaying after a few hours. So if you don't get rid of it, it will make everything die. So these fat separators work really great to get rid of the sperm through the spout, and then you get completely clear water. There should have been a slide in between here that actually says that we have figured out this for many Caribbean coral species. So my colleague, Dr. Valerie Chamberlain, actually made coral breeding reference sheets where all of these details can be found there. They can be found on the Coral Restoration Consortium website, so that nobody has to reinvent the wheel, and we now share this information with everyone who would ever want to do coral spawning work. The same goes for settlement queues. Again, it's not one recipe for all the species. Some species like CCA, other species prefer more open space on seeding units, so you got to have a tailored approach to get successful settlement on your seeding units or settlement substrates. The other thing that has greatly improved is the actual development of these settlement substrates. As much as it's really nice to use small plugs or small whatever people can use for settlement substrates, the fact that we can now outplant these by just wedging them and not needing any attachment devices greatly reduce the time and cost of outplanting. So it definitely increases the scale of which we can do larval propagation. And then again, I talked about this already, but the development of the crib allowed us to do this type of work without the need for land-based facilities, which is a great step forward. So by now, all of the bottlenecks that I highlighted earlier are almost gone, and basically two main ones remain. Of course, there is post-outplanting survival success that is still low because, again, the stressors on the reef are still there. It's not that we cannot do anything, and I will talk about that later a little bit, but one of the main bottlenecks that used to still be there in the last decade, we're also actively working on. Sorry. Working? Yes. And actually that went hand in hand with something fairly beautiful that happened about a decade ago, which is there was a big shift in how people thought about this type of work. It used to be every scientist and every restoration practitioner doing things for themselves, and people actually started seeing the beauty in collaborations. So up until around 10 years ago, we started hosting training events for mostly the Caribbean Basin, also some other locations in the world where these methods are now shared with everyone. And having these types of training events now allowed a lot of people all over the Caribbean to do this type of work. Of course, having more people do this work immediately results in doing this work at a larger scale because simply more people are doing it. But it also allowed us to actually test new technologies by having more and more people test different things at the same time. So it really greatly accelerated the speed at which we can develop new technologies to do this type of work. Basically, we've been developing technologies for all 4 steps of larval rearing, so the gamete collection, larval rearing, larval settlement, and long-term survival. And for all 4 of those steps, we've been trying to increase the scale, increase the transferability, so like how easily applicable it is for others without the need for fancy systems, even though fancy systems are very cool, improve the success and decrease the costs. I'm going to start talking about the step of gamete collection, which I'm actually going to highlight the partnership between Curacao and Bonaire. But before I can do that, I'm going to highlight a partnership that is actually on Curacao between SECORE International and Reef Renewal Curacao. Reef Renewal Curacao is they started doing asexual fragmentation work, the first on the island, and they are by now the biggest group that's doing this, but they started around 2014, 2015. They were trained by Francesca from Reef Renewal Bonaire. And what they did is, of course, they fragmented different genotypes of Apropora cervicornis from all over the island, which allowed us for the very first time to actually collect from this species from one site. And it was the first time we were able to rear this species on Curacao, allowing us to learn about basically everything there is to learn about this species. The recruits that were made that year are still growing on the reef right now, so this was a great success, and that made us realize, hey, working together with asexual fragmentation organizations actually has a lot of benefits because they bring all the genotypes together so that we don't have to go find corals all over the island. And that brought us to a collaboration with Reef Renewal Bonaire. In 2018, Francesca visited us for a training event in Curacao. The year after, we started a partnership which has been very fruitful. You're going to see it this week, but Francesca's outplants, or like the outplants of Reef Renewal Bonaire, are insane. They're very successful, and it definitely allowed us to learn a lot about this coral species. Other than the fact that they were learning how to do coral larval propagation work, we were able to collect more from this species, which we did. So, for instance, one of the things we were testing using the outplants in Bonaire was testing all these different individual gamete collectors, but in a good spawning event here in Bonaire, it looks like this. So we were thinking, is there really a point of placing all these individual spawning tents? Can we not make one massive tent that fits over the entire outplant section? So we tested that. This is basically a massive party tent, but it is a spawn collector. It has like the actual funneling system on top, which you cannot see in this picture. It worked, but it wasn't great. It's definitely still a work in progress. It would have some more applications, such as, for instance, in Florida right now, people are making coral spawning hubs. So the last few corals that are left on the reef are brought to one spot to allow them to actually find each other when spawning occurs. So something like this could also be applied in those types of situations. But the building of this massive spawning net for a big outplanted thicket also inspired us to think of the coral collection tree, or the coral tree collector, which basically is a really big spawning tent that fits around a nursery tree. We've been testing this in the last few years in Miami, and it does work really well. The only downside is that you need to let your fragments grow like quite a lot larger than you usually would before you outplant them. But it does work. Nevertheless, I'm bringing this up not so much because it could work as a nursery tree collector, but I'm actually bringing it up because last week someone said, hey, that's a great idea, because with all these excessive heat waves that we are currently facing and bleaching events, these things could actually be used as shades for the nursery trees instead of having to move them up and down in heat waves. So that's definitely something we had not considered yet, definitely not something we have thought about before, but definitely something that's worth exploring in the future. Second step of larval rearing, and second step we are developing tools for, is the larval rearing work. Again, I've already talked about the cribs enough, but they have drastically increased the scale at which we can do larval propagation work. And the next picture was going to be a picture of our partners in the Dominican Republic, our partners from Fundamar. They recently shared a photo with us of 6 of these cribs out on their reef, and they can now actually rear up to 6,000 larvae and produce up to 6,000 settlement units at the same time that can be outplanted to the reef. Like is an incredible effort that they are doing with just 10 people. So we're getting somewhere. Step 3 is the larval settlement phase. And I want to briefly talk about direct seeding, or direct larval seeding to reefs, which is basically eliminating the step of settling larvae to these settlement substrates and outplanting them to reefs, and instead having your larvae settled directly to reefs. Benefits of this could be that you no longer need to produce settlement substrates, which would decrease costs. It also eliminates the outplant time. So again, it decreases time and costs. And the actual outplanting step of it's a lot of handling, and it actually has it can have bad impacts on your survivorship, because you're moving these to the reef, and we do see that handling the seeding units has a negative impact on survivorship of your corals. So basically, they have been doing this using these mesh enclosures in the Philippines already. Peter Harrison has been testing this method. They've been very successful. So we started testing this in Curacao a few years ago. And even though this method did result in recruitment to the reef, the amount of larvae needed to create one recruit was up to like 2 orders of magnitude higher than using the traditional outplanting method. And especially with larval supply going down every year, we did not think that was a feasible tool to use in Curacao. We did, however, also test it here in Bonaire last year, because Bonaire definitely has reefs where there's a lot less algae growing. They have like cemented proper cervicornis rubble that is overgrown by CCA. So we did another trial here. Results are still pending because we need to wait until these recruits are big enough to have an idea if it actually worked. But we did, however, find something new here in Bonaire, which is using these seeding enclosures to seed coral larvae directly to settlement substrates. We basically just used one of these square enclosures, and we placed 900 settlement substrates under it, and we put swimming larvae into those enclosures, and it worked really well. I think all of those Decor 11 performers are thriving on the reef right now, I hope. And you would think, why do this instead of using a crib? And as much as I really love the crib, because It does work really well. With the heat waves we're experiencing every year, it's becoming harder and harder to rear larvae in the surface layer of the water because that gets extra hot and the crib is floating at the surface. So as much as I hate to admit it, we might have to start looking for ways forward to do other types of larval rearing at scale, still without or with limited need for land-based facilities. So this could be a step forward, and we are now working on the next design of these enclosures to make this more of an available tool. And then the last step, which is outplanting and then long-term survival of corals. As I said, right now we are outplanting by simply wedging these in a reef substrate. It works well. We can do up to 1,000 units with 4 people in one dive, but that can still be faster because imagine the people in the Dominican Republic having to do 6,000. It's still going to take them quite some time and some people. So we're doing scattering trials right now. Our team in Mexico is doing this, where they are deploying seeding units from the mid-water column and even just from a boat. Results, again, are pending, but they are actually getting some pretty good retention of the seeding units on the reef. So if that would be possible, we can definitely start outplanting at much larger scales, which would be another great step forward. And then there is a very last step, which is the one that is always the hardest and the one that people are the most have the most criticism on, which is long-term survival. Of course, there is not a whole lot we can do the moment these corals are on a reef, other than, for instance, co-culturing with grazers, and you outplant your coral settlers together with grazers on a reef, which we'll hear more about tomorrow. Basically, if we don't do that, we leave our settlers on the reef and they're on their own. But there are things we can do prior to outplanting to increase their fitness, to give them a little boost, to give them a better chance of fighting with what's facing them out there. One of the there's a lot of things rewind. There's a lot of research going into this. I'm not going to go into all of it. I'm just going to highlight the one because we'll hear more about it tomorrow, which is heterotrophic feeding. And you would think, of course, feeding coral settlers is an easy way to give them a boost. But up until very recently, we actually didn't know that most Caribbean species can already eat as soon as 4 days after settlement. So what you see here is a Dicosonia stokesi settler that's 4 days old, immediately devouring Artemia nauplii. And an intern that worked with us, Robert-Jan Geertsma, actually figured out that most of the Caribbean species that we really often work with in this type of work can already eat as soon as 4 to 6 days after settlement. So that made us think we can actually start feeding corals right after settlement and feed them for a short time before we outplant them to reefs. Now, Artemia nauplii are, even though they are fairly easy to culture, you still need land-based facilities, and also Artemia don't really belong in the Caribbean Sea. So we started thinking about why not trying to feed our settlers inside a crib using natural plankton. All of you that ever did a night dive knows that the moment you turn on your light at night, you attract a lot of plankton. So why not use this to actually feed our settlers? So we tried that inside a crib. We attracted a lot of weird little critters. These are definitely all too big for coral settlers to eat, but the smaller ones I couldn't take pictures of. But we fed settlers using basically just a dive light that was hanging in the crib, and there's a lot of information that you don't need. But basically, we fed them with Artemia and with plankton. And after only 7 days of feeding, the sizes of the fed settlers were two times larger than the unfed settlers. And after 3 months post outplanting, survivorship was higher for both of the fed treatments. 3 months is not super long term, so we will definitely score this again in October to get survivorship after a year. But it's looking really promising. So right now, which is ongoing this week, is we are actually feeding our coral settlers inside a crib using a solar light. And those settlers are nicely eating every day. And this is a really easy way to feed your settlers for like 1 week, 2 weeks prior to outplanting, because we don't even have to go turn on the lights. The sun does that for us. Our field assistants are scoring this experiment today, so I hope to have some results about this very soon. All in all, I definitely think that by now larval propagation is definitely a feasible tool for restoration, if not one of the most feasible tools to do large-scale restoration, especially with all the new technologies being developed and all the collaborations that are ongoing. I think we can definitely start making a difference in this field. Of course, we could have never done this without all of our partners. Definitely special thanks for Reef Renewal Bonaire for all the work we did here together. And thank you to DCNA for inviting me. I'd be happy to answer any questions.
Yeah, as you were saying in the beginning, if we got inspired, I was already a fan, so I speak for myself. I think that both ex situ and in situ are very important tools, and it's great to learn more. Are there any questions for the people here? Then we move on later to the Zoom participants. Yeah, okay.
Thank you, Kelly. How do you get the plankton in the crib? Like I see how you attract it with light, but
I have a good picture of the crib right now, but it has windows on the sides and it has a hatch on the bottom that opens. So it's basically half open. So the windows are out and the hatch is open. So by having the light in there, all the plankton can just swim in.
oh, nice. Good. Don't you have predatory then?
Yes, but so far we went to check on it every day. There's a few small fish inside the crib, but the survivorship is very steady. So it's not like the predators are preying on the settlers that we know of.
Yeah, that was actually also my question. Like, what's the difference if you have the net and you open it and you feed it and you have predators in it with the natural situation? What are you improving against the natural situation? What are like the stresses of post-mortem mortality? That's maybe the same question.
Yeah, so basically by using the light, you really attract the plankton that's already normally dispersed on the reef. You concentrate it in one area to have your settlers feed. We definitely don't know. Like we are also thinking of applying this potentially to larger scale nurseries, maybe even in situ nurseries for asexual fragmentation programs. But we don't know if having the light out there all the time could actually mess with, for instance, the spawning cycle of corals. So this is something we're testing right now for settlers, and we need to explore further how this impacts further steps of the process.
But you do have a clue what causes post-outplant mortality? Is it predation or is it
Post-outplanting mortality is a whole array of different stressors. It's one of the biggest ones is competition with algae. Yeah, because of eutrophication, overfishing, pollution, the whole picture. And by feeding settlers, you make them bigger, and the bigger they are, the better they are at competing with these algae. Predation is an issue, and I feel like it's more of an issue, for instance, in the Pacific, where there's still a lot of little fish that are eating on coral settlers. We have not had severe issues with predation, but there are, for instance, little crabs that eat the corals, and there's always going to be things out there that are going to be eating the settlers, but it's not a big issue we're running into right now.
In what extent do you look at surface currents already? Because you're aiming to do direct larval seeding, and that's also a problem that we face with rubber reefs, that there's no surface current data. So because we attach the measurement tools to a buoy, it's already at half a meter, and that's not where the thing happens in this case. So.
Yeah, I mean surface currents. You mean just like yeah, basically currents shift, right? So it's been an issue that we ran into when we developed these cribs. The first prototypes were square, and having a square thing floating at the surface was a big issue because there's water pushing against it and it was always breaking. So what we did was we made the cribs, for instance, in a boat shape with two bows, so that whatever way the current comes from it, it just swings with the current.
No, but I mean for the settlers. So if you, I think you want to know what is the best place to put the crib to then release the settlers. We already have an idea of using abiotic factors to do that, or you're not there?
No, definitely not. So the way we do it right now is when there's settlers in the crib, we take them out manually and we outplant them to the reef manually. When we do the direct seeding, we still take them out manually, concentrate them into a bag or in a container, and we bring them to an enclosure on the reef.
Okay, yeah. Thanks.
We have a lot more questions. But is there any other questions?
The direct
rearing or whatever, you have like underwater on the reefs netting, so it has to be but you also like do the algae growth as well.
Yeah, definitely. So these enclosures are only set up like the day that the larvae are actually ready to settle, which again depends on the species. So that the moment you add the larvae, the net is still completely clean, and then it can stay in place for 3 to 5 days before it basically becomes too dirty, and the only thing you can do then is just remove it.
You also affecting the algae is growing because you're excluding the herbivores or no?
There are still some fish in there because you can never, you place this underwater, so there are still definitely some herbivores and little crabs under there, unfortunately. Some damselfish as well. But yeah, it's a 3 to 4 day process, and it doesn't completely seal to the ocean floor, so things can still get in and out. But we don't scrub. In the trials that we did, we didn't scrub the ocean floor beforehand because we want this to be a feasible tool, and if we're gonna have to scrub the reef before we do larval rearing, like before we do outplanting, it's going to be a little complicated.
No one else? We have a lot of questions also in queue. We have a question from Alessandra, which is as follows. What environmental factors are important to take into consideration for higher settlers' survival rate once outplanted on the reef?
Yeah, that's of course, that's the key question, right? The only thing, so we cannot change the environment. We, as restoration practitioners ourselves, we don't have a big say about policy making. I mean, I would say make sure that your coastal runoff stops and that you don't develop the shore anymore, but we don't have a say in that. So we have to deal with what's already there. So we do pick our outplant sites based on that. So you don't want to go outplant in a reef that is completely overgrown by macroalgae, where there's no coral left, because there's no coral left there for a reason. So we pick our outplant sites based on like, seeing if there's still some recruitment around and seeing if there's actually available substrate to still outplant in. We're also not going to outplant your seeding units in sand because they're just going to roll around. So there's definitely, we still need some 3D structure and some CCA and some recruits to be able to say, okay, this site actually could work for restoration.
Thank you. Another question from Jeroen. Can you also give the settlers a small heat stress to adjust them to heat waves?
I do not know the answer to that question. We have tested, so on Curaçao, we actually had an interesting phenomenon where we had a warm water plume in front of our desalination plant. And we do know that the corals that came from in front of that desalination plant and the offspring from the corals in front of that desalination plant were better resistant to heat stress. But exposing them to heat stress just for a few days and then outplanting them, I don't know if it works. We've never tested it. I think it's more of a genetic thing where if the parents are resistant, the offspring will be resistant, but I don't know.
All right, I'll choose one last one so that time to switch and you can have a break. Does attracting plankton with lights at night not deprive the corals in the area from food?
It might. I do have to say that light is so bright that I think it's attracting plankton to everything. However, the crib is our crib in this case is deployed in a very sandy area where there's no other corals around. But that is definitely one of the things we should take into consideration when we would move forward with something like this.
Thank you.
Thank you.
Thank you so much.